We have a MOSFET device over here, and we must find the small signal gain of all of this configuration. Now, to find the small signal gain, we simply draw the small signal module. This infinite capacitor means that in the small signal module it will be a short circuit, so nothing special here. And all of our voltage sources will have to be set to 0. That means that they will be short circuited to the ground. This is the AC ground. Similar to how normal ground works, but in the small signal module. Now, this is the small signal module of the MOSFET device. How much current is this dependent current source producing here? Well, it's nothing but V1GM. Step number 1. Name all of the currents. There is a current flowing upwards from here. How much is it? Well, it's going to be minus Vout over RG. Right, we understand why it's minus, because it flows from the ground upwards, and the polarity here is the plus is over here and the minus is on the ground. Right? Now, some of it flows over here, and some of it flows over here. How much is this current? Well, V1GM. How much is this current? Is this current minus this current. Now, both of them combine and then flow again over here. How much is this current again? Minus Vout over RG. We understand why? Because this current has to split into two and then combine again. Now, how about here? Well, there is a current starting from this input current source and then it flows over way to here. And we can name it here and here, right? It splits into two. We can name it, but I will not do it for now. Trust me, we can do it, but we won't. Now, there are two loops here. It's this one, I'll name it L1, and this one, L2. Step number 2 is to take a KVL for both of these loops. For L1, we enter a negative terminal, so I'll put this with a minus sign, arbitrarily. Then we enter a positive terminal, I'll put with a plus sign, plus V1, and then we enter again a positive terminal because the current flows downwards. So this is going to be, from Ohm's law, remember, R equals V over I minus V out over RG times the resistor, which is Rs. All of this is going to be equal to 0. Now, let's take a KVL also on this node over here. Minus V out, the voltage here, minus because we enter a negative terminal, see it, we enter from a negative terminal. Then there is a positive voltage difference over here. So it's going to be some kind of VRO over here. So I'm going to name it VRO, and plus there is also another voltage difference from here to here. This voltage difference is how much? Again, like before. Now, how much is this VRO? Well, now I notice that I can do a KCL on this node here, which is the same as this node here, node D, the drain of the device. And if I do a KCL on D, this is step number 3, in order to find all of the missing currents, because see that we have here a voltage, right, which we cannot express it with something that we know in this circuit. Well, this is very simple. The current that flows from here to here is going to be this current minus this current. Therefore, this VRO can be expressed as RO times this. I kind of forgot to mention that RO is the resistance that appears here due to channel length modulation. I go more into detail into the basics of the MOSFETs in separate videos, so you can check them out later on. Now, if we go and replace this VRO all the way to here, we will have two equations where we will have this V1 unknown. Well, we can go ahead and solve this equation in relationship to V1 and then replace this V1 onto here. So in this equation we will have a V1 expression and then replace it over here. It's basically how to solve a system with two unknowns. Alright? Hopefully you know how to solve a system, a linear system at that, and therefore the output is going to be, and therefore Vout over Vin is going to be, if you do the math, I leave the math as an exercise to you. Therefore, in the end, Vout over Vin is going to be this expression over here, where we have known quantities, GM, RG, RO. These are values that we are going to know from the circuits. Noticed that we had to bias these gates properly with two resistors connected like this as a voltage divider with a battery, but it didn't play any role at the final result. So we don't have any resistor over here, R1 or R2. Also, this capacitor, because it's very large, we say it is infinite, played also no role in the small signal, the calculation of the small signal gain. This capacitor protects the circuit and it does not interfere with our gain over here. Again, go ahead and solve this system yourself so that you can practice and you can perform these things very, very fast in your exams. Alright, check out the MOSFET playlist over here for more MOSFET exercises and MOSFET basics. Study well and take care. Bye bye.